Okay, so today's materials, graph paper, notebook paper, pencil, and calculator. We are going to graph absolute value functions. So if you want to just write down your title, you can start on your graph paper with this. And we're going to graph just one at a time. Now, last Tuesday, we talked about function types, and I actually showed you an absolute value graph. Does anybody remember what shape absolute value makes? Well, where's a good place or what's something that we could do with the materials that we have to see what it looks like? Put it in the calculator. We can graph it in our calculator to see what absolute value of x looks like. So everybody grab your calculators. And let's go to y equals. And how do we get absolute value again? So how do we get absolute value again? Second zero enter. Good. Finding that absolute value. You're welcome. It's all right. Second zero enter absolute value of x. And then once you have it typed in y equals, you can go ahead and hit graph. Now, if your graph looks funny, remember go to the standard window by hitting zoom 6. So zoom 6 will get you to that standard window. So what does absolute value look like? It looks like a V, and that V shape has a vertex. Remember we talked about vertex when we talked about parabolas? It's the part where it changes from increasing to decreasing. Where's the vertex of this graph? 0, 0. You're exactly right. Now, if you notice, V's have basically two linear parts that come together at that vertex, right? And if they're linear, they have a slope. What do you think the slope is of this line to the right of my vertex? Looks like it goes up a certain amount and over a certain amount. What do you think? 1, 1. You're exactly right. If you hit second graph and go to the table, it also gives you some points. And if you were to plot those, can you see how it's like 1, 1, 2, 2, 3, 3, 4, 4? And if you go the opposite direction, so if you go up to the negatives, they're very similar, and that's what makes that V shape. So back to your graph, we're just going to plot a few points on our graph. We're not going to get too crazy with it. The main point that I want you to plot is the vertex. So put you a dot at 0, 0. I also like to label my vertex on these problems because some of the homework that you have tonight will say, what is the vertex? So if you want to go ahead and label it somewhere, the vertex is 0, 0. And then we're going to go up 1 over 1 in both directions to make that V shape. Now, as long as I see at least 3 dots, you should be fine. So the vertex in the middle, then one on the right and one on the left. And that's all that we need to do. Just a quick graph there. Up 1 over 1, we have that V shape. All right, let's graph our second equation. Y equals absolute value of x plus 2. Now, on this one, we want to graph these on a separate xy axis. So draw a new xy axis. We also want to make sure that we're graphing these on graph paper. So let me give some of y'all some graph paper here. Make it look exact, because when we do some of these other problems where maybe it doesn't go up 1 over 1, we're going to have to look at it differently. Okay, so absolute value of x plus 2. Notice that plus 2 is outside the absolute value. Let's go back to our calculator here. Let's go back to y equals. Right arrow and put your plus 2 there at the end. So what do we think this plus 2 is going to do? You're exactly right. It's going to take that whole graph and shift it up 2. And that's how we describe the transformation. I'm pretty sure we did some of that back in Math 2. Remember how we described? That's right. So numbers that move, that are at the end and are positive, are going to make it move up. So that's something else you have to do on your homework, is describe the transformation this moves up to. So if it moves up to, that means our vertex is at a new spot. What's my vertex? 0, 2. Very good. It doesn't move anywhere left or right. That would be the first number, but up 2 is the second number. And then the slope is still up 1 over 1 in both directions. And so there's our V shape. What do you think would happen if I had a minus 3 at the end here? It would go down 3. So let's try to see what would happen if we put a plus 2 inside the absolute value now for our third problem. So let's go back to our graph, our calculator. Let's put a plus 2 inside that absolute value and get rid of that plus 2 on the outside. So make sure you delete that plus 2 on the outside, just absolute value of x plus 2, and the plus 2 moved it which way? To the left. Remember how it's opposite of what you think when it's with x. Opposite of what you think. So this one moves left 2. And then our vertex would be at what point? Good, negative 2, 0. We're still going to go up 1 over 1 to make that V shape. So make sure you have at least 3 points plotted, the vertex, then 1 on the left and 1 on the right. So let's make ourselves a little guide over here to the side. We might add a few more things in this guide, so maybe make it a little bit bigger. But if it said y equals the absolute value of x, and then outside the absolute value plus a number, which way does it move? Up. Good. If that changed to minus a number, it moves so if it's added or subtracted at the end, it moves up or down just exactly how you think it's going to go. Positive up, negative down. But what if there is a number on the inside? What if we're adding a number on the inside? It goes left, just like this example that we just did. So minus in a number would go so remember, if it's with x in those absolute value bars, or in other cases that we have in parentheses, because this works with any equation that we have, it's going to move to the left if it's positive and to the right if it's negative. The reason it does that, if you guys remember from Math 2, is because when we find x-intercepts, we set something equal to 0 and solve. Remember, another word for x-intercepts is where does it equal 0? So it's like we take this equation and set it equal to 0 and solve, and when you solve, you do the opposite. Okay, let's do another little what if. Let's see if y'all remember. What if I put a negative in front of the absolute value? See if I remember what that does if a function starts as a negative. It is a solution. Let's graph it and see what happens. Go to y equals. I'm just going to clear that out. I'm going to start with a negative. That's exactly what happens. It flips it. But we don't usually say flips. We say another word besides flips. What's a fancier word for flip? Not rotate, but it does start with an R. Reflects. It reflects over the what? the x-axis. That's exactly right. When you put a negative in front of the equation, it's going to reflect over the x-axis. So it does flip, and you can draw that, but what we say is reflects over the x-axis. Okay, so that's your little guide. That's your little go-to that you want to look at for things that happen. And we're also going to talk about a few more things that can change things right now, but we're focused on that. All right, let's try another problem here. My board wants to pause for a second. But right now there are things that we can do without graphing, right? Can you graph these without graphing them on your calculator? Yeah. If you have a number at the end, it goes up. You got a number at the bottom, it goes down. We're going to skip these u-tries for right now because we've got some other stuff that we've got to do. And there is our y equals negative x. So let's graph that one. So we're starting at 0, 0, but because of the negative, we're going to go down. So go down 1 over 1 when you do this one. Since it reflects over that x-axis. But vertex is still 0, 0. I'm going to skip the u-tries today because I want to make sure you got extra time to finish up last night's homework. You're welcome. If you have that one graphed already, you can go ahead and write down this problem to the right. Y equals negative absolute value of x plus 2. I like to start out with my description first. What's happening to the graph? Well, it starts off with y equals negative, so the negative tells us it. Good. Then I have absolute value of x plus 2. That plus 2 is inside the absolute value, so what's it going to do if it's inside? It's going to go left 2. And now we're ready to make that graph. So we always start at 0, 0. If it moves up, down, left, right, we start with that first. So this one's going to go left 2. It doesn't move up or down, so it's just going to be on that x-axis. But then it reflects, so we're going to go down 1 over 1 in both directions to make that V. So what is the vertex of this graph? Good. Vertex is negative 2, 0. Do you have to make the graph to state the vertex? No, you could just see which direction it moves, right? Left would be a negative value for x, and then up would be a positive value for y, and just opposite for left and down, or right and down. Any questions so far? Now, if you want to use your calculator to graph these, that's okay. You can type them in y equals and look at the graph, especially to double check to make sure that you graphed it correctly. You could also get a few points, but I only need 3 points. The vertex, 1 to the left, 1 to the right. Okay, let's try these two. These are kind of combinations where we have some things together. All right, let's start with this first one and get a good description for us. So how would you describe the transformation of this? Well, down one, I heard that first. Now, this one doesn't have a reflection because it doesn't start as negative. But down 1 works. What else? And left 2. So this one is still going to open up because it doesn't start with a negative. Now the next one, that one would be a little different. So let's go down 1 and left 2. That's going to be our vertex. It starts as a positive, so we're going up 1 over 1 in both directions. And what are the coordinates of that vertex? Good, -2, -1. If we go left 2, that's the x value. We go down 1, that's the y value. So -2, -1. And this is the kind of stuff that you're going to be doing on your homework. Does this make sense? How does it feel? Good. You remember some of this now from Math 2? How we moved, translated. It was towards the end. So, okay, if you got that one down, go ahead and write down the next one. Okay, let's describe it. Y equals negative, so what do we say? Good. Reflects over x-axis. I know that's kind of long to write, but write the whole thing out. Then x minus 3, was the minus 3 tell us? Good. Write 3. And then I see a minus 2 at the end, so it moves down 2. Good. Some of y'all are whispering it, but I still heard it. All right, so remember, make your vertex by the left, right, up, down. So this one is right 3, down 2. So there's my vertex. Then it reflects, so we need to go down 1 over 1. And then make a V, or in this case, an upside down V. So what are the coordinates of my vertex? Good. And remember, you can get it from the description. Right 3, down 2, positive 3, -2. So once you know that it makes a V, you really don't need that graph anymore. You don't need that calculator anymore. You can go from there with figuring out your different points. All right, what happens when we put a number in front? What do you think that could enlarge or shrink? That's right. It's like a dilation. Remember how we talked about those back in Math 2? It does dilate the shape. Let's figure out what happens with it exactly. Or Carter, you got a guess for us? It does increase the steepness of the line. You can actually think about this value as being like slope. So our slope, remember, is rise over run. We wrote that down last week. And in this case, it's like 2 over 1. Now, this one doesn't have anything added or subtracted on it, so that's why we can treat that like slope. But it does change if you have more numbers in the problem. But we're going to keep it just simple and treat it like slope for us. So this one still starts at 0, 0 because it doesn't move up, down, or left or right. And it has that slope of 2, so we go up 2, right 1. Oh, as the translation part? Well, we actually don't describe it as slope if we talk about it translation. Remember how we talked about it as a stretch or a compression? Remember how we did that? So, maybe. So how do we describe this? Does it get steeper or does it get wider? Steeper. So that is a vertical stretch. It reminds me of the two guys on Home Alone. This one's not Harry. This is Marv, the tall, skinny one. He's like stretched out. So anytime your slope is more than 1, it's going to do a vertical stretch. And then you have to say of how much. So this does it doesn't want me to write an E. This does a vertical stretch of 2. That's how you would describe that transformation. Now this one over here to the right, though, has a 1/3. So that means we're going to go up 1 over 3. So what's going to happen to that picture? Good. It's going to be a horizontal stretch, and you could also call it a vertical compression. I've heard it called both things. So a horizontal stretch or a vertical compression, because if you compress something vertically, it's going to kind of squish out. Like, you know when you have a hamburger, right, and you press down the top and it's like, psh, goes out the sides? So we can call it horizontal stretch of 1/3. And then you could also put vertical compression, just in case you see either one of those. They are interchangeable. I've taught out of many different textbooks, and some of them say vertical compression, and some of them say horizontal stretch. But either way works. Okay, let's see what else we have going on today. Oh, we're going to write some things down on our notebook paper now. But if you want to write it on your graph paper, you can. For these 4 problems, we're going to write equations that model these functions. You just need one line saved between each of these, and if you want to put it on your notebook paper, you can. You can leave it on your graph paper if you would like to. Either way is fine with me. Was that Miss Lemons or somebody else? Miss Lemons' laugh? Her laugh just brings us all joy. My son laughs really loud too, and it's funny because he might be sitting there watching like a YouTube video. And the other day, I told him normally I let him just like watch it without having earphones on, but I told him the other day, I was like, you've got to put some earphones on and watch this because you're about to drive me nuts. And so he's sitting there watching it, and he goes, like that. And then he went, bah! And started like laughing really loud, and I like jumped. I was sitting there making food, and I was like, oh my God, I about like threw the pasta or whatever I had like everywhere. He scared me to death, but he will just like, he's got this loud laugh. But sometimes he'll just chuckle like, like that. I'm like, and then he'll laugh really loud. All right, guys, so let's go through and write the equations for these. Remember those kind of steps that we wrote at the beginning? That will help you write these equations. So first off, if we want to just move right 3, what do we need to do to move right 3? A minus where? Inside. So Start off with y equals on all of these and start off with absolute value of x. And then we have that minus 3 inside that absolute value. So that's all I need for the equation, but make sure you have y and x and those absolute value bars in there. How do I do a down 7? Minus the 7 on the outside. So only absolute value of x, and that minus 7 goes there at the end. Now we've got some combination ones where we put some things together. Left 4 and up 5. Just start with them kind of one at a time. How do I do left 4? Plus 4 inside the absolute value with x. How do I do up 5? Plus 5 on the outside. Good. Okay, and our last one here, reflected over the x-axis, then right 1 and up 2. Start with the negative for the reflection. Good. Minus 1 on the inside for right 1. Add 2 on the outside. Very good. You can always double check these. Remember, you can plug them in y equals and look at it. Did it do the same thing? Is it reflected? Does it look like it moves right 1 and up 2? Look at where that vertex starts. You could also type it in or look at the table instead of looking at the graph. All right, last thing that we're going to do, we have graphed these. We found the vertex. We talked about the transformation. We used the transformation to write an equation. And now, changing gears just a little bit, I'm going to give you some tables, and we're going to write an equation from the tables. Now, if you're given a table of values, what should you probably do to help you write an equation? Make a graph. Hence the graphs. All right, so copy down these tables and then go ahead and plot these points. Y'all remember how to plot points, right? It's been a while, but it's a good refresher. I feel like that one unit in math too, that's all we did was plot points, that transformation unit. Then we got away from it. While you are copying down these graphs, let me just tell you about the next 2 days. So these are our last 2 examples for today, and then you guys will probably have at least 45 minutes to finish up last night's homework and do tonight's homework because they're both due tomorrow. Tomorrow we do have a little something to finish up for this unit, which is the absolute value key features. And also we've got a few word problems that we're going to do real quickly. So we're going to have about the same amount of lesson today for tomorrow. And then you'll have a review worksheet to do as well. So we don't have a full review day for this unit, but all of you did really well on the quiz yesterday. So the stuff that's on the quiz and then what we are doing this week will also be on your test. But they're all pretty related, so make sure you study and review, or just make sure you do that review worksheet, and then that will get you ready. So no full review day for this unit, okay? I know you've started up your college classes too, so you probably got a lot going on, but I'm trying to give you lots of class time to work. All right, while you guys are plotting your points on your paper, I'm going to plot them here on the board. Remember, the first number is your x value, and the second number is the y value. So left 6 up 2. If we plot them correctly, we notice it makes a V. What do you notice about this first problem here, this V shape that it makes? If you describe the transformation, how does this transform? It looks like it just moves left 4, right? Our vertex is now here at this point, which is left 4, and it opens up. Think about the sides. We're going up 1 over 1 on both sides. So there's no slope involved in this one. It opens up, so there's no reflection. It doesn't shift up or down. It just moves left 4. You could, but with Math 3, they have more shifts in them, so you got to be careful. All right, so let's write the equation for this one. If it just moves left 4, we would say y equals, good, absolute value of x plus 4. The plus is inside the absolute value. All right, last one. Let's plot those points. And then let's make that V shape that we have. And let's first focus on the vertex. The vertex is here. So how did it move from 0, 0 from the origin? It moved left 4 and down 1. Now, it opens up. But almost, if you think about, there could be some more numbers, but I would look for where they repeat. Like these are repeating, so that must be the sides. So this must be the vertex, but it's not always the middle number. Sometimes I put a few more on one side than the other side, but just look where it repeats, and that's usually your vertex. So left 4, down 1. It does, because notice on this one, we went up 1 over 1 on the sides. Do we go up 1 over 1 on the sides here? No, how far do we go up? Up 2 over 1. So this one also has a vertical stretch of 2. Because it's making it steeper on the sides. So if I were to write this equation, that vertical stretch starts at the beginning. That 2 is there at the front. 2, absolute value of x plus 4 minus 1 at the end. So be careful of that vertical stretch because you might see that as you go through your problems. So, question? All right, so your homework tonight, finish last night's homework. If you want to do that first, you can. Or you can start tonight's homework, which is this worksheet that you have. The first 6 problems you want to graph on graph paper. And then these next problems on the front are all about writing the equation. This one down here says honors only, but remember that's you. We're all honors in here. And then on the back, it just says describe the transformation and write the vertex. So you don't have to graph. And then write the equation. And then write the equation. And then you got 3 more that you have to graph here on the side. And these bottom ones are matching. Okay? Now what I recommend for the matching one, type the equation in the calculator. See which one matches with the graph. That's the easiest way to do it. So you have 6 to graph on the front and 3 to graph on the back. So if you want to get those out of the way first, you can, but make sure that you graph on graph paper. You go take one and pass it around. One for you. Here you go. Y'all can take one and pass it to your table group. Mm-hmm.